Hi everybody, today I will present our project Hopbot. Our project members are me, Eray Sözer, Batuhan Yalçın, and Eren Berke Demirbaş. Our coordinator and supervisor is Çağatay Boşdoğan. Now I will show you some problem cases which a ground-based vehicle will fail at. Jumping over a cliff, driving on a rough surface with many indentations, and jumping to the second story of a burning building. But if we design a jumping robot, we can succeed in all of these situations. This kind of a robot can be used in search and rescue operations, cave and planetary explorations. One of the most important systems of a jumping robot is its jumping system. To create a jumping energy, we decided to conserve the compressed spring energy into jumping energy. And to achieve that, we decided to use cam and follower system, which can compress and decompress a spring. But to have a big jumping energy, we needed a sudden release of energy. And to achieve that, we decided to design a cam which has a drop in it. And our initial sketches look something like this. Our cam and follower design ended up looking like this. And as you can see in the animation, as the cam rotates 360 degrees, it first compresses the spring, and when it reaches the drop, it releases that spring. Another system in our jumping robot is the driving system. We used a two-wheel driving system. Each wheel is controlled by one micromotor, and it can go left, right, forwards and backwards using the motor combinations shown on the screen. When we put together these both systems, our final assembly looked like this. And here's an illustration showing how our jumping works. First, the spring is uncompressed, and as it gets compressed, our angle between the leg and the ground gets higher, and when the spring is released, the robot launches into the air.
This was our initial design of the Hopbot and jumping mechanism, but after ANSYS analysis, we showed that we should change some of these designs. And let's talk about our ANSYS parts. Let's begin with spring force analysis. We first calculate the force due to the spring, then we define materials, then within a minor meshing size, we analyze our system under the spring force, and we saw that at leg region we have a critical deformation. Then we change our design to more stronger one, and even we change some of the materials from PLA filament to aluminium alloy. To get higher jump, we also try to decrease our weight. After finalize all the changes, we reach the 0.7 kilogram.
Another analysis we made is calculate the landing force. To calculate the landing force, we need to know mass and the maximum drop height of the robot. And using those, we calculated the maximum potential energy and convert it into kinetic energy, which then will be converted into work done by the ground to stop the robot. And using an estimated indentation value, we calculated the landing force to be 135 newtons. Using that landing force, we also run a wheel simulation and found out that a wheel with 8 connections to the center decreased the stress and deformation by a lot and gave us a good strength to weight ratio.
It is circuit connection for electronic parts, 2 TC for driving boat, 1 servo for compressed spring, and to power up these motors, 11.4 LiPo battery, and to power up Arduino and infrared receiver, we use 9 voltage battery. The reason of using infrared receiver because it was cheaper, and this is the functionality test of electronic parts. That's it, all the motors are working. And this is for our driving test. As you see, this is our jumping mechanism. We calculate necessary torque to get full cycle, but due to the additional friction losses and power losses, it couldn't reach the full cycle. We can change it with using more powerful servo motor, or we can change the cam profile a little bit and it can finalize its path. But due to the Eren get infected by the Omicron, we couldn't continue our mechanism. As a conclusion, from theoretical to real-life application, we gained lots of the new information. We worked on multiple disciplines, and as I explained in previous slide, we get some solution to our jumping problem. For the future of the project, if it can be upgraded to autonomous robot with using some additional sensors, It can be used in search and rescue missions and some exploration missions, which jumping has highly big advantages. Thank you for listening. Thank you for all of our TAs, and these are our referrals.